Okay, from section 1.3, this is number 23, and this is radioactive decay. It says a half-life of phosphorus 32 is about 14 days. There are 6.6 grams present initially. Express the amount of phosphorus 32 remaining as a function of time, t. So A, we have to write this down. So the amount we have is the amount as a function of time equals my initial amount, which is 6.6, and then I'm going to take half of that every 14 days. So if my time would be 14, 14 divided by 14 is 1, but then I might have some fractional part. So if my time was 28, 28 divided by 14 would be 2, so I'm going to use time divided by 14, and that's a half-life. This is kind of the half-life formula. In other words, if my time was 14 days, I would take half of that. If my time was 28 days, 28 over 14 is 2, so that'd be a half of that, then another half. So that'd be 1/2 squared. So this is the way we set these up. Okay, this is for half-life. Approximately, and then it says the letter B, when will we have 1 gram? So we want this 6.6 times 1/2 to the t over 14 to equal 1. Okay? Sorry about that. Okay. So we just graph this and graph 1 and check the intersect. All right? So let's put this in over here. We can see this. Let's see if we are okay. Like this. Good. And we turn this guy on. And let's try 6.6 on Y1, 6.6 parentheses. And instead of 1/2, I can just use 0.5. It's the same thing. It's a little easier, right? And then we're going to raise that. So that's going to be caret, and that's going to be t over 14. So I'll write caret, and then I'll write parentheses because I got a fraction. I don't have a t, I call it x, divided by 14, parentheses. And that's this part. And then down here I've got 1. Now what I'm going to do, I'll just start with zoom 6 and see what we've got. And you can see this is the 6.6. And there's the 1, and you see we're way off. So let's change that window around, and we'll go to window, and we'll start x equal to at 0, and maybe we'll go down to 20 like we did before, y to be 0, and maybe it looks like we're going to be around 1, so we can actually just call this 2 and make this 0.5 like before, spread it out, and let's graph that and see what we've got. And I don't even see the other curve, so it looks like I'm going to have to go out farther. Let's go back to the window, and let's make this 40. Let's see what we've got. Yeah, there we go. Now this is our 6.6, and there's our 1, and that's where they intersect. So we'll go to second calculate, second calc, intersect 5. First curve. Now see, my x is 20, so I got to move away a little way over here. There it is. You can see it coming down right there. So there's my first curve, enter. There's my second curve, enter. And enter again. And 38. So t is approximately 38.115. And that would be, I guess, days. Okay. Days later, okay. Okay, so that's number 23.